Have you ever wondered how real cloud infrastructure gets built? I mean, not with a bunch of clicks in a console, but with pure code. Well, today, that's exactly what we're going to do. We are building a complete, secure AWS network from scratch using nothing but the command line. So, let's dive in.
So that's the big question, isn't it? It sounds complicated, maybe even a little scary, but honestly, it's one of the most powerful and repeatable skills you can have. In this explainer, we're going to pull back the curtain on the whole process, one command at a time.
And hey, before you start worrying about how much a pro-level setup like this might cost to experiment with, get a load of this. The total cost to create all these resources, run them for about an hour, and then tear it all down is roughly 7 cents. Yep, that makes this an incredibly accessible and valuable skill to practice.
Okay, here's our game plan. Think of it like a blueprint for a house. First, we'll lay the foundation. Then, we'll hook it up to the outside world. After that, we need to direct all the traffic and, of course, secure the doors. Then the really fun part, we launch everything and test it out. And finally, we'll cover some pro tips and, crucially, how to clean up.
All right, first things first, let's get into section 1, laying the virtual foundation. This is where we create our main network container, the VPC, and then we'll partition it with what are called subnets.
So what is a virtual private cloud, or VPC? You know, this analogy on the slide is just perfect. Imagine it's your own private plot of land in the huge world of the AWS cloud. It's completely isolated from everybody else, and everything we build from this point on is going to live inside this boundary.
And this is how we claim that land, with just a single line of code. We use something called a CIDR block, which is really just a fancy way of defining a range of IP addresses. And this one command tells AWS, hey, set aside over 65,000 private addresses just for me. Boom, our network officially exists.
Okay, so now we have our plot of land, but we don't want just one big open field, right? We need to divide it up for different purposes, and that's exactly what subnets are for. They're like the individual rooms on our plot of land, letting us group and isolate different kinds of resources for security and just plain good organization.
And we're essentially building two types of rooms. A public subnet is like the lobby of our building. It's where we put things like a web server, stuff that needs to be accessible from the public internet. The private subnet, on the other hand, that's our secure back office. This is where the crown jewels live, like our database, totally shielded from any direct access from the outside world.
All right, our foundation is down, the rooms are marked out. Now it's time to move on to section 2, connecting to the world. We're going to do this by setting up gateways. These are basically the doors that let traffic in and out of our new building.
The very first and most important door is the Internet Gateway, or IGW. And it is exactly what it sounds like. It's the main two-way front door for our entire VPC. We just create it, attach it to our network, and just like that, our public lobby can now communicate with the rest of the internet.
But what about our secure back office? I mean, our database server might need to go out to the internet to download software updates, right? It needs a way to get out. That's where the NAT gateway comes in. It is a brilliant, secure, one-way door. Our private servers can talk out to the internet, but the internet cannot come knocking on their door. This is an absolute must-have for any secure architecture.
Setting this up with a command line is a really logical three-step dance. First, we create and attach that main front door, the Internet Gateway. Simple. Next, we have to reserve a permanent public IP address. That's the elastic IP, which is just a static IP that won't change. This gives our one-way door a fixed address. Finally, we create the NAT gateway itself and we stick it in our public subnet, which gives it a path to the internet to do its job.
Okay, we have our building, we have our rooms, we have our doors. Now for what is maybe the most critical part of this whole build. Section 3, directing traffic and securing doors. This is where we set up the rules of the road for our network, using route tables and security groups. Think of route tables as the GPS, or the traffic cop, for our VPC. Every subnet gets its own route table, which is basically just a set of rules. So for our public subnet, the rule is simple. Hey, if you see traffic that's trying to get to the internet, send it to the Internet Gateway. And for our private subnet, the rule is if you see traffic for the internet, send it over to the NAT Gateway. It's all about making sure traffic flows exactly where we want it to. Now, if route tables are the GPS for the whole neighborhood, security groups are the bouncers at the door of each individual server. They're a stateful firewall, which just means they're smart enough to remember connections. And they let us create super specific rules, like, okay, anyone from the public internet is allowed to talk on web port 80, but that is it. It's security at the server level, and it's incredibly granular.
And this slide right here is a perfect example of a core security principle called least privilege. Look at the web server rule. The source is 0000/0, which means anywhere on the internet, and it's allowed on standard web ports. Makes sense. But now, look at the DB server rule. The source isn't an IP address at all. It's the web server's own security group. This is so powerful. It means our database can only accept traffic from our web server and literally nothing else.
Okay, the blueprint is done, the foundation is solid, and our security is tight. It is time for the best part, Section 4, the payoff. Let's launch our servers and see this whole creation come to life.
So, what we're going to do is simulate a classic two-tier application. This is the backbone of so many websites out there. First, we launch a web server right into our public subnet. Then, we launch a database server into our nice, secure private subnet.
So, after we run the commands to launch those instances, it's the moment of truth. We run this query right here, and we're basically asking AWS a really simple question. What is the public IP address of that web server I just made? This is how we're going to go find it on the internet.
And there it is. Test complete. When you take that IP address and you paste it into your web browser, you'll see the server's welcome page. It is live on the internet. And you know the best part? Our database is totally hidden, tucked away safely in its private subnet, only reachable by our web server. The architecture works exactly as we designed it.
So, we built it, we tested it, and it works. But our job is not quite done yet. Let's move into our final section, Beyond the Build. This is where we'll talk about a few crucial tips for production and the absolute importance of cleaning up after ourselves.
Yeah, it's really important to know that what we built is a fantastic starting point. But to take it to production, you'd want to harden it. You would never leave a security rule open to the entire internet. You'd lock it down. You'd add a NAT gateway in every availability zone, so if one fails, you're still up. You'd add another firewall layer with network ACLs, and you'd definitely turn on VPC flow logs to see every single bit of traffic moving around. These are the steps that turn a blueprint into a fortress.
And honestly, this might be the most important lesson of the day. Clean up your resources. To make sure that 7 cents doesn't accidentally turn into $70 next month, you have to delete everything you created. And here's the key. Do it in the reverse order of how you built it. That way you avoid dependency errors. So terminate instances, delete gateways, then subnets, and finally the VPC itself.
So there you have it. We went from a completely blank command prompt to a fully functional, secure, multi-tier network in the cloud. You've seen the logic, you've seen the commands. You now have the CLI blueprint. So the only real question left is the one on the screen. Now that you have the blueprint, what will you build?